Good morning. This is another topic we discussed from crystal physics. The crystal structure already we discussed in the previous topic discussion time. The 7 types of crystals. The one is in a hexagonal closed packing formations, right? Then today we discussed in the crystal structure FCC, that means face center cubic. Then another one is in a hexagonal closed packing structure. First we discussed in FCC. The FCC is a arrangement of face center atom and the corner atom in a cubical formation, because we take a cubical structure to discuss in all the properties to discuss of crystal physics. So here the face center atom is 6 and corner atom is 8 to form of in a cubical structure. So this 2 atom will be formed in the 4 different characteristics of each and every crystal system. One is a number of atom per unit cell. The second one is in a coordination number. Third one is an atomic radius, and final one is an APF. So this 4 we discussed in all the types of structures in a crystals, right? Then any one it will be changed. The finally we get some conclusion to based on the number of atoms is occupied in the unit cells. So here is 2 atom, one is corner and face. So the corner we get 1/8. That means the 8 atom is shared in. So 1 atom is shared in 8 atom, and in total number of atoms, so we get a number of atom per unit cell is 1. And the face is the 6 total phases is formed in cubical structure, but the 3 phases we have formed in the sharing of that atoms. So we get in 6/2 is equal to 3. So the total number of atom to be formed in FCC in a unit cell is 4. The next one, atomic radius. So the atomic radius we taken from in the edge of the atom and the middle of, that means the face atom, we get that. So we get in one triangle to the form of ABC like this diagram, right? So we get that based on the Pythagoras. Finally we get the atomic radius R equal to A root 2 by 4. So the assignment to find the answer to we get some idea to form of BCC and FCC. One is now why the atomic radius is changed from BCC and FCC, and another one is now compare the coordination number for BCC and FCC. So the atomic packing factor of the FCC, we get the final to the form of APF is equal to the number of atom per unit cell into volume of the atom by volume of the unit cell. So the number of atom per unit cell is in a 4 in FCC. Then volume of the atom, it's look like in a sphere. So we have formed in 4/3 pi r cube. So we know that the radius of FCC root 2a by 4. So we substitute from there. Then denominator term is a form of volume of unit cell. We take a cubical formation. So we get in a cube. So finally we get that 0.74. That means 74% is occupied of atom to form in FCC. The next one we discussed in the properties of hexagonal closed packing structure. So this is a very important topic we discussed in crystal physics in all the times, right? So the properties of hexagonal, the one is in the coordination number is 12 and contained to the form of 6 atom per unit cell. Then covalent bond structure, then ionic crystal, the excellent corrosion behavior, the grip stability and strength property to the forming. So this is the structure of hexagonal, right? So the corner atom is 6 and middle means base atom and the middle atoms. So the corner atom, base atom, middle layer to the forming. Finally we get that. So this is 2 plus 1 plus 3 is equal to 6. The total number of atom per unit cell in SCP is 6. Then atomic radius is very simple, because that corner atom will be attached. We get that atomic radius A equal to 2R or R equal to A by 2. So we find from the next topic from the SCP is in a calculation formation, the calculation of C by A ratio. This is a very important topic we discussed from the HCP. So we form in some mathematical steps to derive. Finally, we get that C by A ratio equal to root 8 by 3. Then the next one we discussed in APF. So the same formula we substitute from here to the APF. Finally, we get that 0.74. So the FCC and the HCP we get that same APF. Then finally, I inform in one slide is summary of all the types of crystal structure: simple cubic, body center, phase center, and HCP. So you get some clear idea about this summary of this slide, and also to be the example of all the structures. So this is all the reference I prepared from this PPT. Right, my name is Vijayakumar. I am from Department of Physics, SNS College of Technology. College of Engineering. Right, thank you very much.